Okay, hi everybody. This short video is going to go over the first assignment for class this semester. This is spring 2023. We will be doing assignment 1 here in module 1, which you'll see in your homepage as soon as you log into Canvas now. Assignment 1, column sort, and if we click this, we'll see it takes us to related documents. After this video is made, this will also take you to a YouTube video, this YouTube video. If you click this link, it will take you to the Files tab, where you can see we're in Module 1, Assignment 1, and there are 3 documents. The first document is sort.pdf. This is your handout for this assignment. So Project 1, column-based text sorting. So for this assignment, we're going to write a simple program that can sort text files. The program should basically, you're going to write code, you're going to compile it, it's going to generate a binary. The binary's name is going to be column sort or call sort. It's going to take an optional argument that I'll explain in a second, and a mandatory argument file. This is the file that we want to sort. So what this is going to do when you run with this argument, you say /callsort file. It is going to print out to standard out the sorted text from this file. So you're going to have to read the file in, apply a sort to it, and then print it out. Now stay with me because there are some details here. You do not have to implement a sort. I will explain how that is done in a second. One catch in this assignment is this optional argument. The argument will be dash followed by a number between 1 and there's really no limit, but there are some physical limits. I guess the maximum could possibly be around 128. We'll see in a second. So you give an argument here. The argument is the column to sort on. So by default, we will sort on column 1, which is basically the first word in the file, or the first word in the line. If you were to input 3, it would mean that you should do the third word. You should sort by the third word on each line. We'll go over an example in a second. First off, let's go over a few objectives just so we understand why we're doing this assignment. So first off, this is a relatively straightforward assignment. This is similar to something you might do in your second semester of CS, or perhaps in data structures and algorithms, to familiarize yourself with a new language. This is the kind of project you would do to familiarize yourself with a new language. In this case, we're doing it in C. So you're going to use this project to learn a little bit about C standard libraries and common ways to do things in C. For that reason, you're also going to learn how to seek some references for these libraries. How do we get ourselves help? We want to use a new function. How do we learn about this function? And then also, just get started writing some of these. My impression is that a lot of students haven't written any C code yet, even though we've talked about it. For most people, you don't really understand the language until you've coded in it. Once you try to apply your knowledge, there's usually some issues. So this is a chance to really work out those kinks. And we're going to be using C programs all semester, so it's important to get this out now. And also, we're going to start thinking about performance. Basically, memory is one big one. We've talked about memory forever. We need to start thinking about memory. We will refer back to this problem later. Sorting is a parallel task. So later in this class, we will talk about memory again and try to explain some concerns with memory once we start using parallelism. So here's an example of the way this program works. So if we have a text file and these are the lines in the text file has 3 lines. You should sort it and it should print out the lines in this order. The second line becomes the first line, the last line becomes the second line, the first line becomes the last line. Because we're sorting on the first word, and in this case, the first letter, because all of these words have different first letters. So, but starts with B, it's the first one, finally starts with F. This starts with T, so BFT is the correct ordering for this. You should already be a little familiar with string comparison from our demo that we did in class. So basically, we sort these alphabetically. If you pass a different argument, you say 2, use number 2, word number 2 as the key, then we will sort line, there, this. So this is the correct ordering for number 2, for key 2. So keep this in mind as you go through your project that we will need to sort on a later column. So, and our indexing starts at 1. We're not indexing at 0, even though computer scientists like to index at 0. We're not doing this for this. So argument of -1 is the default, and it sorts on the first word in the line. So here are a few hints. I recommend that you look at all of these hints. They will help you. Particularly, I tell you what functions to use. You're new to C. So if you want to learn how to open a file, well, these are and read a file, these are the functions you should use in this case. They will make your life the easiest. I'll show you how to look up documentation for those in just a second. Here are some additional calls that will help you. Here's the string comparison function, which we actually implemented ourselves in class, but there is a standard string comparison function. There's also the qsort routine. Qsort is a function that will sort. So you do not need to implement a sort. You just need to use this sort. This problem is about how do you arrange memory to do sorting efficiently, not how do you sort. And hopefully you'll see throughout this assignment that the way that you lay out data makes a big difference for how you do this assignment and in the outcome performance that you get. Anyway, you can read through these. You do not have to use every one of these functions, but I am making it clear that these are functions that you can use. And for example, string tokenizer is a good function. You may or may not use it. It may make your life harder. It depends on your implementation. Likewise, there are a few cases where you will want to call exit. If you reach an error condition, you'll want to call exit 1 so that we know it was an error. You will see this later in this file because we have assumptions and errors. If your code works well, if everything goes fine, you should return 0. Returning 0 from main is the same thing as calling exit 0. But you should prefer to return when possible. It is neater in the way that the program is organized. We'll only look at space characters that separate words, but you may have more than one space. So if there are 10 spaces between the first word and the second word, you still start at the second word. We're not comparing spaces. The max line length is 128, which means that you can just assume this is true. If you find a line that is longer than 128 characters, you can print an error and then exit. Make sure you print to standard error. You'll need to use fprintf for that. That detail is listed here at the bottom. So you'll want to check the arguments. You'll want to make sure you put out errors if you get incorrect arguments. We have cases for when the key doesn't exist. Empty lines, file length, invalid files. You want to read each of these and make sure that you follow these requirements. If you have questions about them, please feel free to reach out to me. These should answer your questions about how do I handle this case. That is what these are made out to be. If you have a special case that's not listed here, feel free to contact me. Or if you don't understand some of these cases, you can also feel free to contact me for that too. If you get an error code, you should use fprintf and the error message. That way we can print to standard error instead of standard out. That way standard out, our good output will go to one place, our error messages can go to another place. So make sure that you do this. Don't print anything to standard out except for the sorted output. If you print other things to standard out, if you just use printf, then it's going to look to us like you have an incorrect result. What you need to do is make sure that you only use standard out for the real output. If you have errors, use standard error. And now here's some general advice about how to do this assignment and future assignments. The first thing is that I've laid out a lot of requirements. It might seem like there's a lot to do. But each task is not that hard. So what you want to do is get the basics working. Start small, set a goal. Maybe a small goal is get command line arguments to work. Develop your command line arguments. Once you're sure they work, move on to the next step. We just need to read the file and print the file back out. Forget the sorting. Let's just read the file and print it back out and make sure that our I/O works. That's a second step. Once our I/O works, let's see if we can sort the lines on key 1. See if we can sort on the first word. Does that work? Once we can sort on the first word, then let's think, how do we sort on the second or third word? These are the things that we want to keep in mind as we go through this. At each of those steps, you really need to test your code. I will test your code to see if it works. You need to test your code too. If it doesn't work, you may lose points, especially if it doesn't follow these requirements. Your code must compile. If your code does not compile, you may receive a grade of 0. Okay. The last thing is that, this project may have a decent size to it by the end. You want to use some method to keep backups. You don't want to be in a situation where your code was mostly working except for one case, and then you tried to fix the case, and now your code doesn't work at all, and you can't figure out how to get it back to normal. It happens to everybody. Don't put yourself in that position. Make copies, store backups. If you are familiar with something like Git, please use Git. Everybody should learn some kind of version control while you're in college. It may not be taught to you, but wherever you work in industry, they're going to use Git or something like Git. And people who learn how to use Git, a lot of times people are resistant to learning Git, and then they learn how to use it, and they say, wow, I really wish I had been using this longer. So I encourage you to learn how to use Git, but no matter what you do, try to keep backups. Don't get caught in a position where you've lost your code or you can't get your code to work anymore because you've made a mistake and you don't remember what you changed. Likewise, if you do use Git, note Git and GitHub are related, but they're not exactly the same thing. If you use GitHub, you must save your code in a private repository. Putting class assignments publicly available is a violation of our academic integrity policy. Please don't put it in a public repository. I don't want to have a meeting with you about this topic, but we will. So, keep your own records. And in that same respect, all of these assignments, at least for now, are individual. So write your own code, do your own work. The purpose of this assignment is to teach you something. If you don't do your own work, you will miss the lesson. That lesson will come back on the exam and it will bite you. And also if you have academic integrity issues, then there are consequences involved. So do your own work. Try to solve the problem yourself. If you have issues, feel free to come and talk to me, come to office hours, talk to our TA. We'll try to get you the help that you need, but do your own work. Write your own code. So next, here are just some submission details. We ask you to submit your files using a specific format. For example, you would submit tl93-p1.tar or .zip. If your file doesn't look like this, it may not get graded. So these submission instructions are very important. Submit your file with all of your files with either a zip or a tar file. Your archive, whether it's a zip or a tar, should have only these files: column sort, makefile, readme. Your readme should include a short summary of your implementation. How does your algorithm work? Why did you do what you did? There is a performance concern I'm going to address at the end of this. Explain why you got the performance that you did. Your makefile can be the one provided. We will talk about makefiles in class, but I will also show a short demo here in a second. Program must compile, otherwise you get a grade of 0. Your makefile must produce an executable named call sort. Your code needs to run on Centaurus, and it needs to be written in C. So you should do your final testing on Centaurus. This is your chance to get familiar with Centaurus before we start doing parallel programming on Centaurus. So you want to make sure that you understand Centaurus by that point. Submit your archive to Canvas before the deadline. And finally, your sort needs to have a certain amount of performance. You'll see in a second that the test code that we give you, or the template code that we give you, times your code. The standard sort program on Linux can sort millions of lines very quickly. Yours shouldn't be much slower. In fact, the sort is written for you. You're going to be using a very efficient sort. The question is, what data are you giving the sort to make it run efficiently? If you haven't caught on by now, this is about pointers and references. How do we efficiently use pointers and references to sort our strings properly? So I think that's about it for the handout. So let's take a look back. If we look at our files, you'll see we have a column sort.c and a makefile. So let's take a look at what those files are. So if we look at column sort.c, you'll see that it starts with relatively simple code. What this code does is, first off, we have a main function. You should not touch this main function. This main function is designed to help us test your code. Basically, what it does is it's going to time the execution of your code and print the amount of time it took to execute on the command line to standard error, so it doesn't interfere with your program output. It is going to call a function drive sort, okay? And drive sort is the code that we are, this is where your code goes, at least to the beginning. So you can pretend drive sort here is main, okay? Write your code as if this is main. Declare functions if you need it. Declare structs if you need it. We'll talk about structs in class. Declare whatever you need. Do it all above this line. And at the end, it should print out the correct result if you've done everything correctly. So that should generally cover this file. You'll want to pay attention to this timing after you get the correct output. If it takes you a very long time to sort, then your code may have inefficiencies. You may need to debug it. Like I said, and we will give more concrete times later, but if your code is taking 30 seconds, a minute to run, 10 minutes to run, then it's too slow. There's ways you can improve your algorithm to make it work faster. So the next thing is the makefile, which we don't actually need to download, but you can download. A makefile is a handy tool for helping us build our code so that we don't have to compile by hand every time. You'll notice I put some extra flags in here. These flags are here to help us debug. We'll talk in class about these a little bit also this week. But for now, you just trust them. This makefile will work for you. So with makefiles, if you have a file named makefile, which we do, if you type make, it will run the GCC, it will run your compiler just like we instructed it to do in the makefile. Now you'll notice we have some warnings because I turned on extra warnings. Warnings are important. In this case, it's just telling us that we haven't implemented our command line arguments yet, and that's fine. So use your makefile. It's a requirement for the assignment to keep the makefile. Generally, this makefile should do it correctly. You will get the correct binary. I recommend you use the makefile without really changing it. Okay, so that really sums up the main idea of this assignment. This video is a little bit longer than I intended, but it really hits all of the key points. If you have any questions about this, feel free to reach out to me, come to office hours, ask in class, okay? Otherwise, thanks for watching, and we look forward to seeing your submissions.